So we're going to do some more identities today, but you don't have to memorize these ones. I give you a little half sheet that has them printed on, so you don't have to memorize them. All right, you just have to be able to use them. And just like any other formula, it's plug and chug, okay? But plus triangle for, trigonometry and stuff. So these are called sum and difference identities. What does sum and difference mean? Yep, add and subtract. So look at this first one. Do you see how sine of something minus something? Here's the only thing that gets people. The negative does not mean that the angle is negative. It's just part of the formula. Do you see how it's sine and it's subtraction? It means you're going to use this one. Do you see the one that's sine and it's subtraction? Okay, before we do anything else, we're going to draw pictures. This is your work for the problem. We're going to draw one for pi over 2 and 2 pi over 3. Pi over 2 is going to be a circle. I'm just going to do this off to the side. Where is pi over 2? Up, down, left, right? Up. Good. And so that point is 0, 1. Bless you. That is the work. That's what I need to see as far as the work goes. Bless you. What quadrant is 2/3 in? Second. Good job. Reference angle is pi over 3. The denominators just match. Do not eat 1/3 of a pi. That's a bad idea. That's a lot of pi. Across from that, you have the big side, which is square root of 3 over 2. Other side is a half, but it is negative. That is your work. You're going to have those two pictures. After that, you just plug in for what the formula says. It's going to be this one right here. It's sine and it's subtraction. Do you see how this says sine of A, cosine B, minus cosine A, sine B, all that stuff? Okay, what that means is you're going to have something times something minus something times something. I am a big fan of set it up blank. You know this about me. Set it up blank, and then you can just go and fill it in. Okay? Now we're going to use our pictures to answer the question. The first one says sine of A. A is going to be the first thing. B is going to be the second thing. So like if you want to label this is A and this is B. Okay? So sine of A, we're going to look right here. Sine is which part of this point? The Y. So 1. And then it says cosine B. So I'm going to look at this one. Cosine is which part? Get the X, so negative a half. Cool. Minus, now I'm just reading along. Just read along with me. The next one says cosine A. So we're going to look at A. Cosine is which part of this? Yeah, 0. And then sine B. So look at B. Sine is square root of 3 over 2. Now, because that's 0, this entire second part just goes away. And what is your full answer to the entire thing? Negative a half is your answer. That's it. For this one, I hope that what your reaction is, hey, 7 pi over 12 is not on the unit circle. I hope that that's your reaction. Like, hey, hold on a second. 7 pi over 12 is not one of the ones I can do. Okay. So what we're going to do is split it into adding two things together that equals 7/12. So it's going to be something 12ths plus something 12ths, but I need for you guys to be clever. And I need for you to pick things that will end up being on the unit circle. So how would you like to try and split it? Or do you have a question?
Yeah, I need to pick
1/6.
Well, they have to be 12ths, but it will be 3. So it's going to be 3/12 plus 4/12. Do you see how 3 plus 4 is 7? It's literally all that we did there. And then you can reduce those. What would 3/12 reduce to? Oh my gosh, pi over 4 is on the unit circle. Ain't that crazy? Plus, and then 4/12 would be pi over 3, which is also on the unit circle. Go us. All right, now we're going to draw pictures for those. Pi over 4 is in the first quadrant. The sides are square root of 2 over 2. I'm kind of speeding that up because we've done this how many times at this point? Okay. Pi over 3, also in the first quadrant. What goes across from the pi over 3? Yep, square root of 3 over 2, and then this is a half. If you want to label A and B, you can. If you don't need to do that. If you're comfortable understanding the first one is A and the second one is B, then you're good. Now, again, you don't have to memorize these formulas. You just need to pick the right one. It says cosine, and it says plus. Yes. We picked two numbers that added up to 7. But we picked numbers that would reduce to something that's on the unit circle. It needs to be something that's actually going to work. If you guess wrong, you'll go, oh, whoops, and try something else. Okay, but basically just 3 plus 4 is 7 is all that we did there. All right, so which one of these formulas are we using? Do you see how it says cosine and it says plus? Do you see how that's going to be this one?
Yeah.
Okay, it's something times something minus, do you see where I'm pointing right here? Something times something minus something times something. So just set it up with all those blanks and just watch me point to this. We're going to fill it in. Cosine A. So look at A. Cosine is square root of 2 over 2. Watch where I'm pointing here. Next is cosine B. So look at B. Cosine is 1/2. Beautiful. Minus, all right, sine A. So look at A. Sine is square root of 2 over 2. And then sine B, square root of 3 over 2. Now, unfortunately, we didn't get a 0 in that one, so I can't cross anything out. Womp womp. But when you multiply fractions, you just multiply the top, multiply the bottom. So looking at this one, you will have square root of 2 over 4. Good. Square root of 2 over 4 minus, now when you multiply this one, square root of 2 times square root of 3, square root of 6. Don't overthink that. 2 times 3 is 6. And then the denominator is 4. Oh my gosh, they already have a common denominator. So you can just put them together and your answer looks like this. I tried to box that in, but I didn't want to run into the next problem. So I probably shouldn't even have tried to box it in. But anyway, that is the answer. Square root of 2 minus square root of 6 over 4, which is a great answer. Don't discriminate. We've gotten weirder answers in here before, for sure. These ones are not on the unit circle. Okay, off to the side here, let's draw a triangle. It's quadrant 1 because everything is positive. We're back to SOHCAHTOA, opposite, adjacent, hypotenuse. Tangent is what over what? Yeah, opposite over adjacent. You can think of it as y over x, but this is angle A. 5 goes here, 12 goes here. What's the other side? Good job, guys. 13. All right, draw another one. This one's going to be B. Again, I put it in quadrant 1 because it's positive. I try to put a lot of these in quadrant 1 for you because, like, what are we doing here? You know. Now, cosecant is the reciprocal of which one? Sine. Sine is opposite over hypotenuse. So this is hypotenuse over opposite. But listen, a triangle only has 3 sides. There is only so much shenanigans you can get up to with a triangle. If you get stuck, put them on there somewhere. You got a good chance of guessing. Okay. What's the other side? All right, that is your work. Now we're just going to pick which formula we're using and plug them in. Cosine, and it is subtraction. Do you see that? Okay, so that's, yeah, this one. Now, I don't want to do this to you and keep moving my paper around. So you're going to have to follow along with this. It's going to be something times something plus something times something. Actually, maybe I can zoom out a little bit and make it fit so I can point. There we go. I can point to it for you. All right, so the first one's cosine of A. Look at A. Cosine is adjacent over take 2. Adjacent over hypotenuse. So 12 over 13. And then, do you see where I'm pointing here? My finger. Cosine B. So look at this triangle. That would be 3 over 5. Perfect. Plus, all right, sine A. So look at A. Sine is opposite over hypotenuse. 5 over 13. Good. And then sine B, 4 over 5. When you multiply fractions, just multiply the top, multiply the bottom. So for this, 12 times 3, 36. 13 times 5. Sometimes you may have to do a side problem. You might have to do a margin problem. You can count on your fingers. You can work it out however you, do you think you have it? 65. Good job. Plus 20 over, oh my gosh, they have a common denominator. We're going to get something over 65. These often already have a common denominator. Usually you're good. 36 plus 20 is 56. And then that's your answer. Cool. So those are the sum and difference formulas. You don't have to memorize them. You just have to draw triangles and be able to pick which one you're using. Were you okay? You guys are handling this. Awesome. We'll do a couple more and then I'll give you another little break because I know this is a lot. All right, double angle identities. Do you see how all these have 2A in them? That's why they're called double angle identities. There's a lot of different versions for cosine. I'll be honest with you, I only ever use the first one for no other reason than it's the first one. It really doesn't matter. It'll get the same answer no matter what. Now I made this part A, B, and C so we'd only have to draw one triangle. Just trying to take it easy on you there. Sine of A is 3/5. We're in quadrant 2. So off to the side here, we're going to draw a triangle in quadrant 2. I'm going to call it A. Sine is opposite over hypotenuse. Now the other side will be 4, but it will actually be -4. So you're in the second quadrant. So that's like your work. Now we're just going to use the formulas and plug in. So it says sine of 2A. Look where I'm pointing right here. Do you see this? It's going to be 2, which I'm going to write 2 over 1. And then times something. Set it up blank. So the first part says sine of A, which would be 3/5. If it's not on the unit circle, you're back to like opposite over hypotenuse. All right, and then cosine A would be -4/5. And you're just going to multiply all the numerators, multiply all the denominators. So what would that give you on the top? 2 times 3 times -4. Get -24. And then 1 times 5 times 5, 25. Good deal. Again, I made this parts A, B, and C so we could use the same picture. For cosine, I just use the first one. It really doesn't matter. You'll get the same answer no matter what. It's going to be something squared minus something squared. Do you see where I'm pointing there? All right, so something squared minus something squared. Set it up blank. And in the first one, you're doing cosine. So looking at this picture, what is cosine? Good. But just as a heads up, when you square a negative, it turns positive, just as a heads up, all right? And then sine goes in the next one. So sine would be 3/5. And then you just kind of do the arithmetic to work that out. When you square a fraction, you just square the numerator and square the denominator. You're squaring both parts of that. So this would be 16, good, 16/25 minus 9/25. Again, almost always with these, you already have a common denominator, so usually you don't have an issue with that. And then just subtract them, so it'll be 7/25. Last one is tangent. We're going to use this one right here, the one that says tangent. So it's going to be 2 times something. I'm going to write 2 over 1 times something. And then on the bottom, it's going to be 1 minus something squared. 1 minus something squared. And in those parentheses, actually, both of them are the same thing. It's going to be tangent. So using this picture, tangent is opposite over adjacent. That would be, yep, -3/4. And they were the same. They both said tangent. So I just went ahead and wrote it in for both. And then you just got to sort that out, which is honestly the harder part. So multiplying these together, this would be -6/4. And then on the bottom, you would have 1 minus, that's for this minus right here. But when you square this negative, it's going to be positive. So this would be 9/16. Bless you. Here's my suggestion. If you're writing with pen, you can scribble it out. If you're writing with pencil, erase the 1 and call it 16/16, because then you can subtract them. So it's kind of like one of those rare times we didn't have a common denominator. We had to get one. What do you think for next step? What is this numerator going to reduce down to? Yeah. I heard somebody say it. -3 over 2. And then on the bottom, when you subtract those, you would have 7/16. All right, almost there. I know you're like, gosh, how much more with these fractions? So whenever you divide by a fraction, you multiply by reciprocal. I would probably not try to do -3 times 16. Do you see something else that you could maybe reduce to make the numbers a little smaller so you don't have to do that? Yeah, 16 divided by 2 would be 8. If you do it that way, it keeps the numbers a little smaller. It's not wrong to multiply -3 times 16. That's -48. It's not that hard, but just trying to keep the numbers littler. All right, so -3 times 8 be -24, and then on the bottom you still have 7. All right, go ahead and flip over. So the last set of identities we're going to do are half angle identities. Do you see how they all say a over 2 in them? The double angles you multiplied by 2, the half angles you divide by 2. The plus minus is for dependent on which quadrant you're in. Okay. I try to keep these in quadrant 1, so just go with the positive. Okay, but that's why the plus minus is there. I hope that your reaction to this is, hey, hold on a second, that's not what. It's not on the unit circle. Okay, so we're going to rewrite it as something over 2, and that something should be on the unit circle. So what is that something? Pi over what? Well, yeah. Why would it be pi over 6? Think about that for a second. Well, 6 times 2 is 12. I think you guys are overthinking that. Is that 6 times 2 is 12? Are you guys focused over there? Okay. So we're going to, off to the side here, draw our triangle for pi over 6. That's our quote unquote work. And then we're just going to pick which formula we're using. We're going to use the positive version. Don't put a plus minus. It's in quadrant 1, so it's going to be positive. Sine is this one right here. So we're going to have a great big square root. Underneath of it is 1 minus something over 2. So just set it up blank. And in the something, we're going to put cosine. So looking at this picture, which one of these is cosine? Square root of 3 over 2. Perfect. If you're writing with pen, you can scribble it out. If you're writing with pencil, erase the 1 and call it 2 over 2 so that we have a common denominator. And that doesn't happen super often, but when it does, it's easy enough to fix. All right, so great big square root. Now you can put these together. It'll be 2 minus square root of 3 over 2 over 2. And so if you divide by 2 and you divide by 2 again, you have now divided by 4. Yes, there is a square root under a square root. Just go with it. And then the last thing you can do there is, what is your square root of 4? 2. So it's going to look like this. And just don't discriminate. It's fine. It's fine. Everything's fine. It's okay. Yes. Hold on, I can't hear him. Go ahead. Cosine is the x value. That's the x value on my picture. If it had said sine, we would have used the y value. Okay. All right, now these, again, I made parts to this so we can just draw one triangle. I said to put it in quadrant 1. Again, I like to do quadrant 1 for these because I don't want you to deal with the plus minus. Just make it positive, all right? This is angle A. We're back to SOHCAHTOA because this is not on the unit circle. Sine is opposite over hypotenuse. And that means the other side is, so do you see how I use the locker combination ones a lot too, so that you can have nice whole numbers and not weird square roots? All right, now we're just going to use the formula and plug in. So sine of A over 2. So this one right here, same one that we just did. It's going to be a big old square root, 1 minus something over 2. So just leave a blank. And what are we going to put in that something? Look at your formula. What does it say?
4a, no.
Cosine is what I was looking for there. And cosine using this triangle would be 12 over 13. I didn't leave myself enough space. So now I'm going to erase the 1 and replace it with 13 over 13 so that I can put those together.
Are you just gonna do that every time for these?
Yeah. It's not hard, you just have to do it. Just probably write with pencil. So if you combine these together, 13 minus 12 is 1, and then that's over 2. So if you divide by 13 and then you divide by 2, you have now divided by 26. Good. It's just 13 times 2. Don't overthink that. Now there is another step. You're going to be okay. What's the square root of 1? 1. Good. And so it's square root of 26 over 26. You guys handled it. You're fine. It's okay. Everything's fine. It's fine. It's fine. Yeah. Yeah. Do you want me to finish these last two and then go? Okay. So we're going to do the same thing for this one. You don't need to draw a new picture because I'm using the same one. All you have to do is look at this formula. I don't want to keep shoving the paper up and down. So can you guys look at this on your paper? All right. It's going to be a big old square root 1 plus something over 2. And what's going to go in that blank? Cosine, which again is 12/13. It's the exact same thing we did in the other one, except what's the only difference? Yeah, it's plus instead of a minus, which is going to change this because when you add 13 plus 12, so you get 25/13 over 2, which is going to be 25 over 26. Again, 13 times 2 is 26 is all that we did there. And then what is your square root of 25? 5. And so your final answer is 5 square root of 26 over 26. You're fine. You handled it. Good job. No, it's not that bad. All right. And then last one, tangent. You're going to look at this formula. So it's going to be a big old square root. And then underneath of it, 1 minus something over 1 plus something. As a heads up, this one's actually going to be better. I know it looks worse at first, but it will be fewer steps, I promise. Just trust me. And inside of there, you're putting cosine, which again is 12 over 13. They're all the same. Using the same thing over and over and over. Can we pretend the one is a 13 over 13? Can you imagine that? Do you have an imagination? So I don't have to erase them. All right, so on the top, you would have what? 1/13, good. And then on the bottom, you would have 25/13. And the reason this turns out better than the other ones did is because conveniently what happens? Yeah, well, and so they cancel. Good. So you just get square root of 1 over 25. And then those both work. Your square root of 1 is 1, and your square root of 25 is 5. So it actually turned out a little bit here.